Hello again, students. This video I'd like to go through a little demonstration on how to do, we're going to cover a little about events, event handlers, delegates, and operators in this one. Not operators, indexers, I'm sorry. So this isn't stuff that you would code all the time if you can't tell. But it is important to go over it just so you understand how it works under the hood. I think it is, at least. So the way I'm going to code this, it is going to require me to make an indexer for this product list. Sorry, I'm in the wrong file here. Let's go back to my product list, and I'm going to make an indexer. So essentially this is going to allow me to be able to find a product in my list by the index, or by a certain integer, if you will. I could also do this with maybe a string if I wanted to do it if I wanted to find a product by the code, but I'm going to go ahead and just make an index for it. So essentially it's just going to return me a product at the second or third or fourth or fifth position, for example. And I'm going to do that using a public method, and it's going to return a product because it's going to be a product at a certain position, and I'm going to use the this keyword. So essentially it's going to return this product, and I'm going to use brackets to signify that this is going to be an index to be able to get this product. So this is a little bit of different syntax, and then you're going to press enter and give it some curly braces. Now the next syntax you're going to see is some get syntax, or some syntax like we use the shorthand getter and setter, and this is the longhand getter and setter. So if you want to be able to get a property, the longhand, you can make a get property here and then give it curly braces again to tell the compiler how you're going to get this property. So you can see at the top here that this is no longer breaking, or it's compiling now, but this isn't compiling because not all code pass return a value. You can see here. So now we're going to show this thing how it's going to return a value. So the first thing I'm going to do is if the index they pass me is less than 0, or the index they passed me was out of bounds of my list of products, then I'm going to go ahead and throw an argument out of range exception. So I'll go ahead and give it the argument it gave me. Throw new. So what this is going to do is it's going to say if they pass me an invalid integer, just throw an exception. So they need to figure that out, whoever's using this list. They need to fix that. Otherwise, if they gave me a good integer, I'm going to go ahead and return the product that is at that index. So now, just like a primitive array, if they pass us an index, we can go ahead and return that complex object of a product. So that is how you do an index. If you'd like to make this a string and make it a code, you can do that using the exact same syntax here. That being said, I'm going to go back to the product maintenance application. Make it a little bigger here because we're going to end up adding a lot of code here. So the first thing I want to do is I'm going to make a variable that's going to hold all these products. And we already had that products from database. I'm going to use that again. I'm going to set that equal to my product service.getProducts. But remember, this returns us a list of products, or an IEnumerable of products. So I'm going to go ahead and cast that to a list again, so I have it as a list instead of an IEnumerable, or instead of an interface type. Just a little bit of polymorphism there. To be able to cast it to whatever type you like. And then from there I need to put these in my product list. So I'm going to go ahead and make a product list. P, I'll just use variable P for products equals new product list. And I'll just use the default constructor there, so it'll just make a new product list. And then I want to say products from database, so this should be all the products from my database. So it should be the 3 or 4 products that I have there. I'm going to say .for each since it's a list. And I'm going to go ahead and put every single one of those products in my list. So this syntax, again, I said that I can use this for get. This is also a lambda into a link expression. So I'm using for each. I'm saying for each product from my database, and I'm calling it X. So for each product in my database, I want to go ahead and call products.add X. So now I'm saying for each product from my database that I'm going to call X, go to products.add and add what I call X to that list. So again, since X is a product, you can see here when you hover over X, because the products from database is a list of product, and then products takes a product. So that's why that works. So now I have my products from my database on my maintenance.load or product maintenance load. So now we're going to start talking about delegates. So now I want to have a delegate on my product list that knows when this thing is called. So if you can see down here, I made a delegate at the bottom, public delegate. So that's the delegate keyword that's going to tell this product list that this thing is going to point to a method. And then I'm going to say, in order for this delegate to be valid, or this method to use this delegate, the method needs to return void or return nothing, and it needs to take in this product list that I have. And I'm going to go ahead and call it changed handler. So if I go back to my product maintenance application, I can say product list dot changed handler, and I'm going to call that here my delegate. So not a very good naming convention, but nevertheless. And I'm going to set that equal to a new product list.changeHandler. And I'm going to say print to console. So whenever this product list changes, I want you to call this print to console method. And you can see that this print to console method is not created yet. So I'm going to go ahead and describe that method here. And now everything compiles because this print to console method exists. And now every time my product list changes, so down here my product list is changing because I'm adding products to it. So once it's done changing, I'm going to go ahead and call my delegate, and I'm going to send it my products. And now, even though it says my delegate, what it's actually calling is print to console. So you can see if you have multiple delegates that point to a method, or one delegate that points to multiple methods, you can be listening for these things to happen, and it'll start firing off events that you're listening for. So once I print this to console, I'm going to go ahead and do a console.writeLine. Your product list has changed. And then I'm going to go into a for loop, and since these aren't collections, it's actually going to be a little bit more difficult. So I'm going to need to do an old for loop, because I can't simply say for each, because they don't implement IEnumerable. They don't have a get enumerator method. We'll cover that a little bit more when we cover polymorphism. So now for each one of these products, I'm going to go ahead and get my product by my index, and since I have this index in this for loop, I can use it. So I'm going to say the product equals the product at that particular index, and it should always be okay because it's between 0 and the count, which is what I'm allowed to do. That's within the bounds of my array. And then I'm going to say console.writeLine p.getDisplayText. I'm going to go ahead and give it a tab. Okay, so now, once my product maintenance loads, and I get my products from my database and load it into my custom product list, I'm going to tell my delegate that I want you to print it to console. I don't really care about this method that exists here. You should know how to handle printing it to the console. Let's go ahead and run it. And now I don't have anything here because I'm not referencing my list, but if we go down to my output down at the bottom, since I'm doing a console.writeLine, you can see that our product list has changed and it prints out all of our products. So you can see how these delegates can be very powerful. And look here at this delegate here. Let me stop running the application. We can come down here and look at this. Uses this delegate, a void object sender event args e. So in order for any event to occur on our form here, it has to conform to this method signature. And that's because the delegate forces it to be that way. So here again is our changed handler delegate on our form that points to our print to console, and we can do that because there's a delegate on our product list that has that method signature. So again, this is a little bit more than you do on an everyday basis if you're working for a company, but it is important to understand how these work in the context. That way you can understand how events happen and how to conform to the events and why you need to conform to those method signatures. So I hope that helps. In the next video, we're going to start covering inheritance. Thanks.